Hi, DJ Jerry here. Welcome you to the next chapter on more calculation. I'll keep it short here to the main point because calculation is a skill and you can only master a skill through practice, right? It's just like math. Okay, but before we practice, the main big idea, what the main big idea that we want to look at. So actually more is just a unit, right? In fact, it's an SI unit. It's a unit to talk about the number of particles. So just like 1 kg is 1000 gram, 1 hour is 60 minutes, like 1 decade is 10, 1 dozen is 12. So 1 mole actually represent this very big number, right? 6 times 10 to the power 23, right? We call it the Avogadro constant. Okay. It's not frequently used in combined chem, more used in the pure chem, but maybe later part I can talk more about this to give you more insights into why this is important. So after that, we talk about relative atomic mass, relative molecular mass. So the word relative we mentioned is in atomic structure is that relative means it's not the real mass, it's just compare. So we compare to what? We compare to the 1/12 of the mass of a carbon 12 atom. So carbon 12 means we're looking at the mass number that's 12, right? Because carbon has other isotopes. So what we are saying is that when they cut the carbon 12 atom into 12 parts and they take out one part, it is exactly 1 unit. So that is why, we take that as a comparison. All right. So we need to know average mass. Why we use the average mass? Because of isotopes. All right. So in if it's atomic, we just use the word atom. And if it's molecule, then we'll be using the molecule. Right. So it looks like two different definitions, but actually quite similar. Just changing atoms to molecule. All right. And there's another term called molar mass, right, which is equivalent to MR. Right, so maybe I just give you an example. Right, so basically molar mass means the mass of 1 mole. Right, for example, MR, if we talk about relative molecular mass of O2 is 32. There's no unit. Relative means you compare, there's no unit. But the moment you talk about molar mass, then we can put in the unit, 32 gram. And why? So mass of 1 mole. So that means we are saying that 6 times 10 to the power 23 O2 molecule, then it's 32 gram. And this makes sense, right? Because 32 gram can't be one oxygen molecule because we cannot even see one oxygen, right? So how can we measure the mass of one oxygen molecule? So actually, that's why the 6 times 10 to the power 3 is to give it a value to make some sense out of it. But most important thing, what we want to know is how do we, the things that we cannot see them, we cannot see atoms, we cannot see molecules or ions, then how do we calculate more? How do we find more? So basically, there's formulas to convert them. So if you look at any more calculation, okay, do take a step back to check. Actually, you're going through these two steps, right? Is M means find more. The first part is always to find more. And of course, this word stoichiometry basically just means mole ratio. Okay, whatever number we see, we balance the equation, or we see H2O, for example, 2 hydrogen to 1 oxygen. So this 2 is 2 moles of hydrogen to 1 mole of oxygen atoms, right? It's not 2 gram, it's to 1 gram. It's just the mole ratio. There may be more than 3 formulas to find mole. I just want to focus which these are the 3 that we frequently use, and with these 3 we can almost solve any questions. Right? So depending on what we have, all right. So if you have mass, take note must be in gram. So I would say that this is the main one that we need to memorize. Right? When you see volume, okay, do you use the 24? All right, this 24 is only for gas. All right, and this is given in the last statement of the periodic table. 1 mole of any gas occupy 24 dm³ of space. So even you forget, you can still use the last statement. They're saying that 24 dm³ of any gas is 1 mole. You can use the max ratio to calculate. If you got x dm³, how many more is that? You just take 1 over 24 times x, which is actually x over 24, which is volume divided by 24. Right? If you forget concentration, don't worry. Okay, this unit will tell you the formula mole per dm³. Let me show you. Mole per dm³ means mole slash dm³ divided. That is your concentration. What happens if you are given another unit for concentration? Right? Let's say, for example, gram per dm³. Then we just change the mole here to mass in gram. So we don't, so even we forget sometimes by looking at the unit, it can help us to recall the formula. So do take note. Volume is seen in two part of it. You got a volume here, you got a volume here. But take note, right? You ask yourself, is it a gas? Not 24 dm cube can only be used if it is a gas. If it's not a gas, if it's a solution, then we have to use a concentration formula. Okay, just take note, in any calculation, we got to make sure that the units are the same before we can multiply or divide. That applies to maths, to physics, not only to chemistry. It's almost all calculation that we do. Right? So 1 dm cube is actually 1000 cm cube. So actually it's like 1 liter is equal to 1000 milliliter. So how big is 1 dm cube is actually equivalent to 1 liter. All right, then after we find more already, then we will compare ratio. Right? We will look at what we are given. Okay, so normally which formula we use depends on the questions, what's given in the question. So that's why we need to practice to get to see a more fuller picture. So try to get to look at some of the videos that how I go through a calculation questions. And normally, whatever is given, right, we will assume is the limiting. Basically, limiting means is the one that's being used up, right? Because when the thing is used up, no matter how much excess reactant you have, right, you cannot produce anymore. For example, H2 plus O2 give you H2O, right? We balance the equation, right? If this is used up, even I have excess oxygen, I will not produce any more water. That's why the amount of water is limited by the one that's been used up. In this case, it's your hydrogen. Okay, of course, there's the steps to find the limiting. So once again, it actually involves also the steps given more ratio and then do some comparison. So catch the video on how to find a limiting, then you get a better picture. All right. So this up to now is for the combined chem. The pure chem, we go a bit more, all right, to learn about the percentage purity, okay, and the percentage yield. All right. So before actually the steps involved is not different. It's still more ratio, just that the last part we need to do some treatment. And we also go through for the pure chem, all right, we also there's also you also need to learn how to calculate empirical formula. And you will realize that actually how we calculate empirical formula is also going through the mole ratio. There's a table given, but it's same thing, it's like a mole ratio. All right, you can catch a short video on how I calculate the formula using how I get the empirical formula, and from empirical formula, how do I get to the molecular formula? All right, that will be more for the pure chem. Right? If not, yeah, that's all for the calculation. Most important thing, look at how I practice, how I solve it, then you practice on your own. Because this is a skill which can only perfect or improve through practicing. But look at the big picture. It's always about more ratio. Why? Because in the equation, whatever number we see, whether in the balance equation or in the formula, they are actually strictly more ratio. Catch you in the next chapter.